Welcome to this preview video on assignment 7 in text processing analysis. In this assignment, you're going to use the AWE untagged corpus, which is in the CMS as a zip file. So you first download that to your hard drive and unzip it. And once you do that, you should have a directory called AWE_untagged. And there are 150 files in here, smaller than the previous corpus we've used for homework assignments. Okay, and you can see that there's a header in each of these files that you'll need to get rid of before you work with them. And the register of each of these files is noted in the first 5 characters. So for example, in the one I have highlighted right now, JA_BI is the register. JA is the kind of the macro register, and then the main register, and then there's a topic or discipline, which is biology in this one. So JA_BI in the title, the file name, lets you know what the register is. Okay, so you're going to write a Python program that uses the default part of speech tagger in MLTK to tag this little corpus. Your program should identify all noun-noun sequences. For example, cell distribution, government policy, where both nouns are common nouns, not proper nouns. Okay, the part of speech tagger in MLTK identifies or distinguishes between common nouns and proper nouns. Proper nouns being like names of people and places and companies, and common nouns are just other nouns, kind of regular nouns, you might say. Make sure to include both singular and plural nouns. For each of the 6 registers in the corpus, generate a frequency list of all common noun plus common noun bigrams. A bigram is a string of 2 words, ordered in descending order, that is, with the most frequent bigram first. Your program should then write out 6 CSV files, 1 for each of the registers, with 2 columns, bigram and frequency. When imported into spreadsheet software, it should look like something like this, right? You have your bigram here in column 1, and then its frequency here. And you have 6 of these files. With a small sample of the corpus, like a file or 2, 1 file is fine. Check the precision recall of your program, of your regular expressions. You'll need to use some regular expressions to look at the part of speech tags. So you need to check your, just do a small sample to check precision and recall. In a docx file, a Microsoft Word document, write a report in which you interpret and compare the frequency of noun plus noun pairs across the 6 registers. Because, like I said, there's some about biology, some about history, so you're going to find differences in the noun plus noun sequences, bigrams. Also report the precision recall measurements in the sample, the corpus you chose in your Microsoft Word document. What you turn into the CMS is a zip file that has your Python program that does the work, your report in prose, as well as your precision recall in a docx file, and then the 6 CSV files that your program creates. And here's a list of those 6 registers if this is helpful. Okay, so that is it. We're going to be combining several things here. We're combining part of speech tagging, which we saw in lesson 8.2, part of speech tagging with NLTK. So you need to use that tagger, right? You'll need to use regular expressions, at least on the part of speech, so you can identify common nouns, both singular and plural. And a list, right? You'll need to use a list there, put things into a list and loop over with a for loop. So you're kind of combining a lot of things into this assignment that we've seen with text processing analysis up to this point in the semester. The way I'd approach this with some kind of pseudocode here, the logic I would approach this with would be this. I would get the file names. I would, change directories into the directory that has all the files, get all their names, the file names, and then I would loop over the 6 registers that I gave you. All right, I'm going to jump back over here. And right there, put this into a list. It is already linked to a list, save it to a variable, and then loop over those 6 registers. Create an empty dictionary that will be used to hold frequencies of noun plus noun bigrams in the current register. And then loop over the 150 files. There are only 150 files in this corpus. It's a small sample of the corpus, by the way. And then if the current file belongs to the current register that you're working with, then you need to discard the header. I would use the re.sub function to get rid of any text that begins with an angle bracket and ends with an angle bracket. So you need to create a regex to get rid of these headers. And you can do it several ways. You could use a counter or something to not have it start paying attention to lines until, what is that, the 9th line or something. An easier way, I think, would be to use re.sub. Just look for strings that begin with an angle bracket and have anything but a closing angle bracket, and then have a closing angle bracket, and then replace it with nothing. That is, just delete it. That's probably the way I'd approach that. And then once you've gotten rid of the header, you tokenize the words with a function, with the tokenize underscore words function at NLTK. And then you tag for part of speech with that, with the POS underscore tag function at NLTK. And then I would loop over the indexes of the tagged words, which are in tuples, right? The tuple is the token, the word, and the part of speech. I would loop over those and use a regex to look at the part of speech. And if the current word is a common noun, and the following word is a common noun, then, by the way, you'll probably need to use a try except block here. When you look at the following word, if you're at the end of the list of words, it'll error out, right? Because there's no following word. It'll throw an index error. So you have to deal with that with the try except block, the way I'd approach that. And we looked at try except blocks. Here in lesson 5.2. You need to review 5.2. That's where we looked at try except. All right, so if the current word is a common noun and the following word is a common noun, as tagged by the NLTK tagger, create a bigram with the 2 words. That is, put them together in one string separated by a space. Do string concatenation, which we've done a lot by this point. And then add or increment the frequency of that bigram to the dictionary that was created up here. And we saw how to do that in lesson 7.4, where we saw how to do frequencies, keep track of frequencies in a dictionary. And then once you've gone through all the 150 files that are in that directory, then at that point, sort them in descending order, sort the frequencies in descending order on frequency, then open a connection to an out file, the current CSV out file, right, for the current register, and then loop over the sorted words and frequencies and write them out to the CSV. That's the way I approach this. These indentations are here on purpose, right? These are levels in the script that things need to happen in. So that's the logic in pseudocode of how I would approach this. Once again, if you have some other way in mind that you'd like to approach this problem, this exercise, you can totally do so. But if you don't know what to do or how to do it, then this right here will do the job. I'm gonna pause the video and look at that. Go ahead. All right. So that is how I would approach assignment 7. Again, as always, I'm super happy to help. If you want to come into my office hours or make an appointment with me if you can't make it during my office hours. And also my TA is very happy to help if you would like some help with this. All right. Best of luck. See you next time.